Yeah, hello everyone, myself Maruti, welcoming you all to Ram Maruti Tutorials. In this video, I am going to explain a method, a contradictory method from real numbers chapter. Okay, so to prove this contradictory method, I have chosen a sum. Prove that root 7 by 3 minus 2 root 5 is irrational. Okay, before dealing with the sum, let me tell you what's the meaning of contradictory method. Contradictory method means a procedure in which the one what is required to be proved, that we take it as wrong. We take the opposite of that. Okay, as we are taken it as opposite, we start solving the sum. We reach to a place where we will be under contradiction, right? We go against to the laws of mathematics, right? We go for opposite of any definition which is already proved. So as we have landed in a place where we are going against to the mathematics rule, then we accept our assumption as wrong. And as we have reached a contradiction, then we say, yeah man, what we have assumed is wrong and what you are saying is right. That is the way of proving a contradictory method. Let's prove it for you. Prove that so and so is an irrational number. So let's start the sum for you. So to prove that, what is the given question for you? It's nothing but root 7 by 3 minus 2 root 5 is irrational. This is what he is asking us to prove. What he is asking us to prove? That prove this one as irrational. Okay, so then what's my plan? Means let us assume in a contradictory method, let's assume that what we are assuming, I said we are assuming the opposite of that. What he is asking us to prove? Irrational. Let us assume it as rational. So root 7 by 3 minus 2 root 5 is rational. So that is what I am proving. It has to be proved as irrational. We are assuming it as rational. Now think about all the rules of a rational number. What is an irrational number? Sorry, what is a rational number? How it looks like? What are the rules? Is the one what we have assumed, is it satisfying all the rules of a rational number? Let's check it out. So we know that. What do you know about a rational number? We know that. Right, rational equals, it looks in the form of P by Q. Any number which is in the form of P by Q is nothing but a rational number, right? But we are not going to keep it quiet. Oh, it's not only P by Q, it is going to follow many more conditions. But still, that is, what is the number we have assumed it as rational? So, root 7 by 3 minus 2 root 5 is equal to P by Q. Why? Because we are assuming it as P by Q, rational number. So, what are all the rules and regulations? Let's write by definition, what are all the rules? The rules are like this. P comma Q are integers. This is the first rule. The P and the Q should be integer. And the denominator, whatever we are having, it should not be equal to 0. Q is not equal to 0. This is the first condition. This is the second condition. And we are having one more condition. That is, the HCF of the P comma Q should be equal to 1. These are the three rules and regulations for a rational number. Now let us check it out. The one what we are taking it as a rational, is it following all these conditions? And not only, there are many more conditions, like every time under root of a non-perfect square can never be rational. Right? That is also one more rule. We'll get back to that one. I'll get back to that. So now let's start working. Now this is the one. Now let's start simplifying that. So root 7 by 3 minus 2 root 5 is equal to P by Q. Let's start simplifying so that we will reach to a place where we land in a contradictory place. Means we are going against the law. Let's solve it so that we reach there now. So let's take the LCM of that. It's 3. It's nothing but root 7 minus, if there is nothing, 1. 1 goes in 3 times. 3 2s are 6 root 5 is equal to P by Q. Okay, still simplifying. Now what I am doing, the denominator here 3, I am sending it to the other side. root 7 minus 6 root 5 is equal to 3p by q. Okay. Now we are having one rule. What is that one? Under root of a non-perfect square can never be negative. I like to write the rule here. Right? Under root of a perfect square. Under root of a non-perfect square can never be rational. You have to remember this one. This is the important rule of a rational. Under the root of a non-perfect square can never be. Do you know what's the meaning of a non-perfect square or a perfect square? You know, 2 square is equal to 4, right? 4 is a perfect square. In the same way, 3 square equals 9. So 9 is a perfect square. Is it okay? And right in the same way, the 16, right? It's nothing but 25, 36. All these are, what are those? Perfect squares. All these are perfect square. If we are having other than that, underneath the perfect square, you have to say it can't be an irrational. Example I like to give, right? Something like root 17. Is it a perfect square? Does it belong to this family? No. So, it's nothing but irrational. You have to remember. Okay. If it is under root of 36, we can write it as 6 square, and square and root gets cancelled. 6. This is a rational. We should know that. This is a, what is that? Non-perfect square, and this is a perfect square. Under root of a non-perfect square is irrational, and under root of a perfect square is a rational. That is also one of the rules of a rational number. To make that rule applicable here, I am working on. So see here. So how many roots we have? We are having only one under root. But here, how many under roots we have? We are having 2 under roots. For that one, what is the only way? Squaring on both sides. If you square it on both the sides, then we will get only 1 under root. So, to eliminate 2 under roots here, this and this, I am squaring on both sides. So that's what? Squaring on both sides. Okay, so whole square equals whole square. There we are having it as root 7 minus 6 root 5, and here it is 3p by q. Alright, let's start simplifying. Root 7 whole square plus 6 root 5 whole square minus 2 into root 7 into 6 root 5 is equal to, the square comes to all the 3. 3 square 9 p square by q square. Till here we have landed now. Now as you all know, the square root red cancel, done. 6 squares 36, and the square and the root get cancelled. It's nothing but 5. I repeat, 6 square 36, root 5 squared 5, 36 into 5. Here the 2 and the 6 is nothing but 12. 2 into 6, 12, and root 7 and root 5, it is nothing but root 35, which is nothing but 9p square by q square. I'm still simplifying, nothing else. Now 36 into 5, it's nothing but 180. It's nothing but, if you remember, it's nothing but 180 here. Alright, 180 plus 7, it's nothing but 187. 187 minus 12 root 35 is equal to 9p square by q square. Yes, we got it. So what was I saying? I want to apply this rule here. For this one, under root of a non-perfect square, we need how many roots? Only 1. To make that as only 1 root, I have squared it on both the sides. But the root, if it has a positive, that will be better. So here the root what I am having is negative. Okay, so to make that negative as positive, I am transposing this one to the other side, and there whatever is there, I am bringing back. I repeat, just to make the under root as a positive, I am transposing to the other side. That is 187, I am transposing to that side, minus 9p square by q square is equal to, it's 12 under root 35. You got it. So see here we are having 2 roots, here we are having only 1 root. But of course, we should isolate that. We should make it alone. But still 12 is there. I want to send that one also away. But still, let us simplify this. So if you take LCM, it's q square. It's nothing but 187 q square. That is, if there is nothing, it's nothing but 1. What should be multiplied to 1 to make it q square? Q square. Q square into 187? 187 q square. You have to remember that. Minus means minus. Now q square goes in q square. Same goes in the same one time. You have to remember that. The same goes in the same one time. 1 into 9p square. 9p square is equal to 12 root 35. Okay. We don't want two roots. We squared it. We got only one root. We don't want negative root, therefore we shifted to the other side, it became positive. And the condition, we need only one root, or only allowed root, therefore 12, and bringing it to the other side. 187 q square minus 9p square by, here it is multiplying, if it transforms, it becomes 12, already q square is there, which is nothing but under root 35. You got it? Now the planning starts. We got under root of a non-perfect square. Please remember, it is a non-perfect square. Now here, if you observe it, let's go to the, here, just now I said p comma q are integers. Here, p comma q are integers, yes. Then the numbers whatever are there, 187, 9, 12, all those are integers. So the addition, subtraction, multiplication of all the integers will be obviously an integer. I repeat, p comma q are integers, we proved it. The other numbers 187, 9, 12, all those are integers. Now addition, subtraction, multiplication of the integers will be always an integer. So here, which implies the entire stuff, 187 q square minus 9p square by 12 q square is also integer. Yes. Now this is what? If this side it is integer, what should be the other side? It should be a rational number. Okay. Then which implies we don't have that. So the one which is toward the other side, root 35 is, what is that? Rational. What's that? Rational according to the calculation, according to present calculation, right? According to the present calculation, we are saying that root 5 is the rational, but that's what he says, but, right, under root of non-perfect square, right, can never be rational. This is the rule. But we know that. But we know that. What do we know? Right? It's a known fact. We know that. It's a known fact. Right? It's a known fact. It's a known fact. What's that? Under root of a non-perfect square cannot be a rational. But we got it as a rational according to our sum. So which means we came to contradiction. We are under contradiction. So our assumption is wrong. So our assumption is wrong. So we made a wrong assumption. So what, as assumption is wrong, so what we write? Which implies root 7 by 3 minus 2 root 5 is irrational. Hence, root. So, hope you are able to understand the entire logical way I have said. We came to the right rules of rational. We reached a contradiction. So, we have assumed it wrong. That's why we reached a contradiction. So, we apply, let's say, our assumption is wrong. What is given in the question, that is right. Hope you are able to understand. Thank you. Signing off. Maruti from Rama. In this channel, I have been placing both math and science videos.